on measures of position? Well, it's known, actually, IQ tests are made up, so the mean is 100 and the standard deviation is 15. It's also known that the scores have a normal distribution or a bell-shaped curve. Part A, find the two scores between which 95% of all IQ scores lie. So all we need to do is take the mean of 100, subtract 2 standard deviations, take the mean and add 2 standard deviations. So 95% of all IQ scores lie between 70 and 130. Well, that means there's a 5% chance of being outside of that range, 70 to 130. So if any score is above the 130, that's considered unusual. And if any score is below 70, that's also considered unusual. So how many standard deviations from the mean is at 145? In other words, if you start at 100, how much do you have to add on? And by how much, I mean how many times do you have to add on this 15 until you get to 145? Well, the answer is 3. So you have to add on 3 15s in order to get to the 145. So it's said to be 3 standard deviations above the mean. Now what about 136? Well, it was 2 standard deviations away when we saw the number 130. It's 3 standard deviations for 145. So 136 has to be between these two, 130 and 145. So it has to be between 2 and 3 standard deviations. And in fact, the 136 is a little closer to 130, so it's going to be my guess is 2.2 or 2.3 standard deviations away. But how do we find out what that decimal is? Well, first of all, find the difference. So in other words, the 136 is 36 points above average. Then, if you divide by the 15, that will tell you how many 15s you have to use. You would have to use 2.4 15s in order to get to a 136. So you'd add 1, you'd add another 1, and then you would add 0.4 of a 15. So 2.4 standard deviations above the mean. What we just described, basically what formula I was using without saying it, is the z-score. The z-score tells you how many standard deviations away from the mean the score is. So positive will be to the right, negative below. And here's the formula. So it may be that you have sample mean and sample standard deviation, but basically the idea is the score that you're given minus the mean divided by the standard deviation. Or if it's the population information right here, then you're going to have the score minus the mean divided by the standard deviation. So here's an example. Not about IQs or anything else, just I randomly made up numbers. So what's the z-score? Well, one thing to notice is that 98 is above average, so the z-score is going to be positive. So we just do this little formula with the numbers. The score minus the mean divided by the standard deviation, it's a positive 2.3. And as I was trying to describe earlier, 95% of scores are between negative 2 standard deviations and positive 2 standard deviations from the mean. So anything outside of that, whether it's to the left or lower than average, or to the right and above average, anything outside those two numbers is going to be considered unusual. And so basically from now on in homework, quizzes, or tests, if the word unusual comes up, that should be a trigger to you to say, oh, do the z-score and see if it's above 2 or below negative 2. Here's another way to use z-score. Suppose that you have 2 exams and here's the scores. So you have the average and the standard deviation for the whole class, and then your score, an 85 on exam 1, a 77 on exam 2. Well, notice that they're both 10 points above average. And you say, well, okay, it seems like I did 10 points above average, and I did the same compared to the rest of the class. But you have to take standard deviation into consideration. So if we do that, find the z-score, then this one would have a z-score of 1.25, and this one just a z-score of 0.83. Being 1.5 standard deviations above the mean is better in this situation. So if the teacher tells the class, okay, you get to throw out one of your exam scores and keep one, you tell me which one it is. It's going to be exam 1. That's the keeper. But unfortunately, notice that neither was over 2.0, so neither was unusually good. All right, on to the next idea, percentiles. Since it has cent in it, it is dealing with 100. So what you do is order the numbers, smallest to biggest, and then you put a marker after 1%, after 2%, after 3%, etc. So that takes 99 percentiles in order to divide the data into 100 pieces. Here's some fancy artwork to say the same thing. So here's the markers. They're called P1, P2. So in other words, if somebody landed in here, they're in the bottom 1%. If they are over here, they're in the top 1%. So in order to find a percentile, you would just say, put a mark right here. I'm talking about this score X. And then you count how many scores are less than it. Then you divide by n, because it's basically saying, okay, I beat 20 out of 150 people. And then to make it a percent, multiply by 100. And don't put it as 67.83%, but just round it to whatever the next percent is. So here's some scores to practice with. Find the percentile for the number 8. So we have that number 8, so you just count how many scores did the 8 beat. Notice that these are already in order. So how many scores did the 8 beat? That's 3 scores. So then that's 3 out of 10, which makes it 30%, or the 30th percentile. Now we need to work the other way around. What if somebody had said, hey, I want to know who is at the 30th percentile? Then we need to be able to do the work to say, hey, that's the number 8. That's the number 8. Okay, first calculate what's called the locator. Basically, all you're doing is taking this 30 and changing it into a decimal. So you divide by 100. Then multiply by the sample size to say go that far, or in other words, go 30% of the way through the data. That's what this little formula says. Now, what if it's a decimal? So if it's any type of decimal, it's like it's saying 3.2. So that's telling you you've got to go to the 3.2 person. So you have to go this one, and then this one, and then this one, and a little bit past. But you definitely have to go past the 7. That means you're going to go to the 8. So when this turns out to be a decimal, then whatever it is, you round up to the next biggest number. So even if it said 3.01, you round it up to the 4 and go to the 4th number in the list. Last possibility, what if it's a whole number? So if it turned out to be a 3 exactly, then what you need to do is go to this one, which is the 3rd, go to this one, which is the 3rd, this one is the 4th, and then average those two, and the answer would be 7.5. Okay, now for a fun example, how about the 83rd percentile? So you begin by changing that into a decimal, multiply by the sample size, and you get 8.3. Like I said, when this turns out to be a decimal, you go to round it up to a 9. So then you just look for the 9th number in the list. There it is. It's a 19. Find the 20th percentile. So for this one, it turns out that it's a whole number 2. So this is the case where you go to the 2nd number and the 3rd number and you average them. So the answer is going to be 5. Next up, box plots. So there's just 5 numbers that are used to create a box plot. You need the minimum, the Q1, median, Q3, and maximum. You may remember I showed you how to use the calculator before to find the standard deviation. Well, that's where the numbers for the box plot are. So can you see it? So when you find the mean and standard deviation, just scroll down, and that's where the box plot numbers are. Almost there. So suppose that we have these numbers. Take a moment to type that into the calculator. You ready? Okay. Um, and then, hey, why don't you let me know, what do you think about this idea of putting pictures on the screen like that? Or, I mean, like that. Or should I make videos for how to use the calculator? After seeing this, if you email me your preference, that would be great. So, anyway, you go to Stat, Edit, type in the numbers. Do I need to pause again? Okay, type in the numbers. All right, here we go. And then you go to the one variable statistics. So stat, and then move over to calculate, and then hit enter. Hey, where'd it go? And then hit enter, and it's going to give you all of those numbers that you need. So then after you scroll down, you will see these numbers for the min, Q1, etc. That's what we're going to use to make the graph. So with the graph, it goes from 2 to 13, and don't just automatically put this rectangle in the middle. So what I did is right here, you see a little dot. What I did for that dot is I took the 2 and the 13 and I averaged them. So add them together as 15, divide by 2, 7.5. Then I put a little dot right there to indicate that's where 7.5 is. Then that gave me an idea where to put the other numbers. Oh, 9, that's going to be a little bit bigger than 7.5. 6, a little bit smaller. Looking at it now, 6 maybe should have been right about here to be a little more accurate. But anyway, you can even divide it into quarters to find out where those numbers are and have it even more accurate. But this rectangle can be shifted to the left or to the right. It can be smashed down really small. It could be really big. It just depends on what the data is like. All right, so that's it for now. See you soon.